Okay, Bismillahirrahmanirrahim. Assalamualaikum and very good afternoon again. Thank you for being here in the Google Meet session for our dynamics class. First of all, I would like to apologize because we have to cancel two classes. I think last week satu class, and then this week on Monday I have also a meeting. So I'm sorry for that. And today we are going to continue with our dynamics lesson. So we have finished with chapter 1, that is the kinematics of particles. So now we are moving into chapter number 2, which is kinetics of particles. So the first subtopic is called the equation of motion rectangular component. Okay, so this is what we are going to discuss today. Okay, let's look at the lesson outcomes of what is expected for you to achieve at the end of this class. Okay, so first we are going to review the 3 Newton's laws of motion. Okay, Sir Isaac Newton, if you are familiar with his name, Isaac Newton has formulated 3 laws of motion. So that this motion we are going to discuss briefly, just to revise our memory on this. And then we are going to go into the Newton's second law of motion, that is called the equation of motion. So we need to understand what is the equation of motion and how we can use it to apply the equation of motion in rectangular coordinate. So this is our subtopic for today, which is we are going to focus on rectangular coordinate. Okay, I think you have, or you should already know what is the meaning of rectangular coordinate. Okay, dalam kinematics pun we have discussed 3 coordinate system ataupun 3 types of component. Rectangular coordinate is the normal xy component lah, xy axis, and then you have normal and tangential component, itu yang kedua, and then the last one is cylindrical component. So for today we are going to focus only on rectangular coordinate, which is xy coordinate system lah. Okay, and the last outcomes for today's class is that you should be able to solve some problems related to this topic. So I'm gonna show you a few example problems lah towards the end of the class for today's lesson. Okay, so before we go into the 3 Newton's law of motion, let's look at who the person behind this principle, all these laws. Okay, his name is Sir Isaac Newton. Isaac Newton lah nama dia, basically nama dia Isaac Newton. He was born in 1643. He was from England. Dia seorang Englishman. Okay, he died at the age of 84 and he studied at the University of Cambridge. Okay, so ini background Isaac Newton, the man who discovered ataupun who has formulated the principle behind the equation of motion. Okay, so dia punya one of his publication ataupun dia punya buku yang famous is this simply called Principia lah. Nama dia panjang, Philosophy Naturalis Principia Mathematica, atau dalam bahasa Inggerisnya is Mathematical Principles of Natural Philosophy. Okay, by Isaac Newton, often referred to as Principia sahaja. In this book, in this Principia, Isaac Newton has explained about the 3 Newton's law of motion, so which we are going to use in this chapter number 2. Okay, buku dia ni published in 1687. Dah lama, very old book, published in 3 books lah, ada 3 series of the book. Okay, so this is a little bit about the man behind the laws that we are going to use today, Sir Isaac Newton. Okay, so we move into Newton's law of motion. I have mentioned that there are 3 Newton's law of motion. Siapa yang remember what is the first law of motion yang Newton bagi tahu? What is the first Newton's law of motion? Anyone? The first law of motion. Ada siapa-siapa ingat tak? F equals to ma is one of the law of motion, but it's not the first law of motion. Inertia is also not the first law of motion. Tak ingat? What is the first Newton's law of motion? Okay, tak apa. I'm going to show you. Gravity is also not true.
Will not change unless a force acting on it.
Correct. Thank you, Ahmad Ferry. Yes. The first law of motion yang Newton bagi tahu is every object in a state of uniform motion will remain in that state unless ada external force yang bertindak pada dia that act on the object. So meaning that if the object is not moving, it will stay not moving. If the object is moving with a constant velocity atau constant velocity, if the object is moving in constant velocity, it will stay moving in that velocity unless ada force yang bertindak pada dia. So this state of first law of Newton motion is known as equilibrium. This is called the equilibrium state, which you have learned in statics. Okay, dalam static you belajar equilibrium lah. Objek itu tidak bergerak. The object stays not moving because there is no external forces acting on the object. So the object kekal pada equilibrium state. This is the first Newton's law of motion. The second law of motion is the one yang our friend bagi tahu just now, which is F equals to ma. This is the second law. Second law states that the force equals mass times acceleration. Ini yang Newton bagi tahu, the second Newton's law of motion. The second law of motion is the one that we are going to use in chapter 2, in this chapter. So we are going to use the second law of motion in this chapter. The first law you have already used in statics, which is the equilibrium. The third law of motion states that for every action, there will be the opposite reaction. So if you, for example, push something with, let's say, 50 Newton force, the object will also apply the same 50 Newton force to your finger, for example. So this is the third law of motion. For every action, there is an equal and opposite reaction. So basically, ini ialah 3 Newton's law of motion, and we are going to focus on the second law, which is F equals to ma in this chapter number 2. Okay. Let's go to the equation of motion. Tadi kita bagi tahu the second law is F equals to ma. F equals to ma is known as the equation of motion. F equals to ma. F is the force, okay? M is the mass of the object. A is the acceleration. So if you look at the how the formula is written, F is written with a bold typeface, which means that the force is a vector. Okay, apa maksud vector? Vector dia ada magnitude, dia ada direction. So that is the meaning of vector. Mass, on the other hand, is not a vector, is a scalar quantity. It has magnitude, tapi dia tak ada direction. And the last quantity ataupun parameter is the acceleration, which is also a vector. Okay, acceleration has magnitude as well as the direction. Okay, so F equals to ma is known as the equation of motion. Okay, and then we go to the there are some formulation behind it. I don't want to show you. If you want to know, you can refer to the book. after some formulation, we get the weight of an object. Okay, the weight will always acting downwards. Okay, acting downwards is equal to mass times the gravitational acceleration g, and through some calculation, gravitational acceleration g is equal to 9.81 meter per second square. This is an estimation of the gravitational acceleration, tapi it is a good enough approximation lah, although the exact value differ from one place to another, tapi kita boleh generalize the gravitational acceleration ni throughout the whole world in the earth as equal to 9.81 meter per second square. Okay, so this is the weight. So mass is a property of matter that provides a quantitative measure to its resistance to change in velocity. Mass is the inertia. Apa maksud inertia? Inertia ialah something yang menghalang sesuatu benda tu daripada merubah dia punya current state. So let's say for example, I am currently static sitting on a chair. My mass is the one that prevents me from moving, something like that. So if you take this equation of motion and rearrange, you will see that the acceleration A is equal to the force over the mass. So the bigger the mass down here, mass is the one being the denominator di bawah pecahan ini. So if the mass is big, is a large number, then the acceleration will become smaller. So mass is the one that resists the change of motion. So mass ini dalam kes ni kita panggil sebagai inertia lah. Mass itu yang menghalang perubahan pergerakan sesuatu objek. Okay, so that is some definition of the mass lah. Okay, mass ni sesuatu yang resist the change, and by resisting the change in velocity, kita panggil mass itu sebagai inertia. Okay, so basically this is the equation that we are interested in, the equation of motion. Okay, and then when we would like to solve problems related to this topic, we need to define our, dia panggil sebagai inertial reference frame. Basically, inertial reference frame ni ialah coordinate system lah. Whenever the equation of motion is applied, it is required that measurements of acceleration be made from a Newtonian or inertial reference frame. Inertial reference frame ni does not rotate, is fixed or translate in a given direction with a constant velocity. Maksud dia, inertial reference frame ni ialah the coordinate system lah. So basically dia mengatakan, statement ini mengatakan bahawa apabila kita nak solve problems related to this topic, we need to define our coordinate system. And from previous chapter, how many coordinate system yang kita ada, yang kita dah belajar sebelum ni? How many coordinate system yang kita dah belajar sebelum ni dalam chapter 1? 3. Good. Ammar Ashraf. We have learned 3 coordinate system: rectangular, normal and tangential, and cylindrical, depending on the situation. Kalau the problem involve rectilinear, straight line punya motion, we will use rectangular coordinate system. If it is a curvilinear motion, then normally we will use normal and tangential coordinate system. If it is moving in a helical motion, 3D rotation, so we will use cylindrical coordinate system. Okay, so for today's lesson, we are going to focus on rectangular coordinate system lah. In the next class, we will learn about normal and tangential, and then finally we will discuss about the cylindrical coordinate system. Okay, so the equation of motion based on rectangular coordinate is basically x, y, and z axis lah. But normally in this course, in this dynamics course, we are only interested in two-dimensional problems. So normally we will only have X and Y axis. We don't have Z axis. Okay, so previously we have the equation of motion F equals to ma. So when we are going to solve a problem related to this topic, we are going to write the equation of motion based on the coordinate system, based on the axis. Based on the axis. So let's say we use now rectangular coordinate x and y. So we are going to write force in x-axis equal to max, and also force in y-axis equals to may. And in the case of three-dimensional problem, you akan ada force in z-axis equals to maz lah. But as I mentioned earlier, normally we don't consider three-dimensional problems, so you are going to be interested in just fx and fy. Okay, and also I have mentioned earlier that rectangular coordinate system ini kita guna for rectilinear motion. Rectilinear motion ini apa? Rectilinear motion is the motion of an object in straight line, in straight path. Okay, so this is the case where we are going to use rectangular coordinate system. Okay, any question so far? Do you have any question on the equation of motion and also the rectangular coordinate system for equation of motion? Tak ada soalan? Okay. So if you don't have any question, let's look at the analysis procedure when we are trying to solve problems related to this topic. What are the steps that you have to take? Okay, the analysis procedure. The first step is to define the coordinate system. Okay, tadi kita dah bagi tahu we have three coordinate systems: rectangular, normal and tangential coordinate, and also cylindrical coordinate system. So for this topic, for today's lesson, you are going to define your XY axis. XY axis ni boleh jadi in the normal orientation, maksud dia X positif ke kanan, Y positif ke atas, or you can also define, depending on the situation, you can define your coordinate system differently in different orientation. We will look at the one of the example problem later. I will show you how can we define the coordinate system in slightly different orientation. Step number 2 is to draw free body diagram. This is important. You should know what a free body diagram is. In statics also, you draw the free body diagram. Free body diagram shows all the external forces acting on the particle, on the object. Okay, so this is important. The free body diagram will give you a lot of marks in the test, in the final exam, in the quiz. So there are marks allocated for the free body diagram. So don't do not think that you don't have to draw the free body diagram, or free body diagram is not important. It is very important. So I want you to always draw free body diagram whenever you are solving problems related to kinetics of particle, related to problems that involve the forces acting on the particle. This is the free body diagram. Number 3 is to draw kinetic diagram. Yang ni, kinetic diagram is, you haven't heard of the kinetic diagram because in statics there is no kinetic diagram, because in statics the object, the particle is not moving. So you don't have kinetic diagram because kinetic diagram is showing the particle's inertia force. Apa maksud inertia force? Inertia force is ma tadilah. If you remember the equation of motion, F equals to ma. F is shown in the free body diagram. ma is shown in the kinetic diagram. So these two diagrams is basically representing the equation of motion. Okay, that is why free body diagram and kinetic diagram is important because they represent the equation of motion itself. Okay. Step number 4 is then when you have drawn the free body diagram and you draw the kinetic diagram, then you need to apply the equation of motion in scalar component, because now we have separated the equation of motion into x-axis and y-axis. So the calculation will no longer involve vector because kita dah separate dia siap-siap. So we don't need to use ij component, but then we use scalar component in x-axis as well as in y-axis. So that is step number 4. Step number 5, if the particle or the object is in contact with a rough surface, kalau dia tengah moving on a surface that has friction, so you need to also include friction force. Macam mana nak calculate friction force? Friction force is equal to the mu. Mu is the coefficient of friction ataupun friction punya constant lah. Mu, coefficient of friction, multiply with n. N here is the normal force. Normal force. Nanti kita tengok what is the normal force. I think you should know already what is normal force. You also have learned about normal force in statics. But in the example problem later, maybe I can refresh your memory on what a normal force is. Step number 6, if the particle is connected to a spring, okay, if there is a spring involved in the problem, then you can also calculate the spring force using this formula. For Fs, the force of a spring, is equal to K. K is the spring constant, multiply with the S, where S is the deformation of the spring. Ini kalau ada involve spring lah. And finally, if you recall the equation of motion, F equals to ma. There is no component of velocity dalam equation of motion itself. So kalau a problem tu requires you to determine the velocity or the position of the particle, of the object, then you need to use kinematic equation yang kita dah belajar dalam chapter 1. Kinematic equation tu ialah V is equal to ds over dt, A is equal to dv over dt, and V dv equals to A ds. Those equations you need to apply if the velocity is needed to be calculated. Okay. And also kalau the problem involve constant acceleration, then you remember 3 equation of constant acceleration that we learned before can also be applied in this chapter, okay, in solving the problem. Okay, so do you have any question regarding this before we go to the some example calculation? Any question? No question? Okay. Okay. So if there is no question, let's look at an example problem 1. Okay. The 50 kg crate. Crate ni is the box ni lah. 50 kg box. Rest on a horizontal surface for which the coefficient of kinetic friction is mu k 0.3. Okay, so you tengok the friction coefficient is given, which means that the box is moving on a rough surface. Maksud dia the surface has friction. Okay, if the crate is subjected to a 400 Newton towing force as shown, so ada satu tali and then maybe somebody is pulling the rope here with 400 Newton force, which caused the box to move. Okay, now what we want to do is determine the velocity of the crate 3 seconds after 3 seconds starting from rest. So basically the situation is you need to be able to understand the situation the box is at rest, not moving. Suddenly, somebody is pulling the rope with a force of 400 Newton applied constantly at 30 degrees, okay, and the box will start to move. So what we want to find out is what is the velocity of the box after 3 seconds. Okay, all right. So what do you need to do? What is the first step here? What is the first step to solve this problem? Coordinate system. Thank you. So the first is to set up coordinate system. So bila kita tengok problem ni, okay, dia bila kita tarik, the box will start to move to the right. Okay, the motion will be to the right. So okay, we will define the coordinate system as usual lah. There is no need to define our coordinate system in different orientation. We just define x positive to the right, y positive ke atas, going up. Okay, what is the second step? After we have established our coordinate system, what is the next step to do? FBD, correct. To draw the free body diagram. Good. So the free body diagram, we will draw it as a two-dimensional box lah. Walaupun box ni dalam gambar dia lukis sebagai 3D, kita draw as a 2D gambar, two-dimensional picture. Okay, what is the force acting on the box? Free body diagram, remember, is to list down ataupun to draw all the forces acting on the box pada masa ini. At this moment, what are the forces acting on the box? Itu yang you perlu lukis dalam free body diagram. Okay, Liu cakap the weight. Good. All objects in the world has weight. Mesti dia ada berat, dia ada mass. So the weight is acting at the center of the object, center of gravity. So W tadi kita dah bagi tahu early in the slides. W is equal to mg. Okay. Okay, Faris Ikmal kata ada friction force. Correct. Okay. Friction force kemudian, nanti dulu. Okay, so first we have mg. Okay. What is the next force yang kita ada? You look here. Normal force. Thank you, Ahmad Ferry. Whenever an object is in contact with the ground, okay, kalau objek tu ada touch the ground, there must be a normal force. Okay, normal force akan ada pointing ke atas. Normal force akan sentiasa follow the surface. Kalau surface tu flat, dia akan point ke atas. Kalau surface tu sengit, dia akan ikut surface yang sengit itu point ke 90 degrees to the surface lah. Okay, so that is the normal force. Tadi Faris ada bagi tahu we have friction force. Correct. Tapi friction force ni bertindak ke kanan atau ke kiri? In which direction?
Ke kiri.
Ke kiri. Kenapa ke kiri? Opposite. Betul. Thank you. The friction will act in the opposite direction of the motion. So kalau you imagine kotak ni bila kita tarik, dia akan bergerak ke kanan. So friction akan melawan dia. Dia akan bergerak ke kiri. So we gonna have a friction force pointing to the left. Friction force saya tulis sebagai FF. Friction force. Okay. Ada lagi tak force yang bertindak pada kotak ni? Good. Component P. Correct. So we will draw a force P acting at an angle, 30 degrees angle. Later bila kita formulate dalam kita punya formula X and Y, kita akan pecahkan P ni kepada komponen. Good. So that completes our free body diagram lah. So basically altogether kita ada 4 external forces acting on the box at this moment. Okay. That is the free body diagram. Yang kedua is to draw the kinetic diagram. Okay, remember tadi saya bagi tahu step ketiga is to draw kinetic diagram ataupun KD. So you must not be familiar with kinetic diagram because this is you don't have kinetic diagram in static. So basically kinetic diagram ini sama. You draw a box also, but you will draw only the acceleration component of the box. So now you see from the coordinate system, you have two axes, x-axis and also y-axis. So the acceleration component must also have only two axis sahajalah. Dia tak boleh ada 3 atau 4 acceleration component. Dia mesti follow the axis. Okay, now I want to ask you, do you have ataupun the box, will it move to the will it move in x axis? Kotak ini, yes, the box will move in x axis, to the left or to the right?
To the right.
To the right. Okay, so that is the first arrow that you will draw. You will draw one arrow to the right and you write max, the mass multiply with acceleration in x-axis. Okay, now x-axis is done. Now you go to the y-axis. Do you think this box will move up or down?
No.
No. Okay, so if the box is not moving up and down, which means that you don't have to draw any arrow in y-axis. So this completes your kinetic diagram. So kinetic diagram will only have one arrow. Okay? Alright. So when you are done drawing free body diagram and kinetic diagram, then we can start to apply our equation of motion. And first we start with x-axis. And if you look at this equation of motion, the left-hand side of the equation, fx, you refer to the free body diagram. The right-hand side of the equation, ma, you refer to the kinetic diagram. So this is why drawing these two diagrams are important. Drawing these two diagrams is very important because it will help you to write down the equation for x and y axis. Okay, let's continue. Now we are focusing now on fx equals to max. Alright, what are the forces we have in x-axis? Look at the free body diagram. Apa force in x-axis yang kita ada?
Px and frictional force.
Good. We have the P force, the component in x-axis, as well as the friction force. Mg and Na, they don't have any component in x-axis. They only acting in y-axis. So you don't have to write them in the x equation. So the component of P is P cos 30. Okay, you see the 30 degrees here. So to get the component of P in x-axis, you will multiply P cos 30 degrees. And then you have the friction force to the left, which is in the negative direction of x. That's why you write it as negative. And friction force tadi kita dah bagi tahu is equal to mu times Na. And is given here mu k 0.3 multiply with Na. Na is still unknown. We don't know what is the value of Na yet. Okay. That is the only forces you have on in the free body diagram. Now equal to look at the kinetic diagram. What do you have in the kinetic diagram? You have max in the kinetic diagram. So you will write in max. Okay. Then we can substitute all the values lah. 400 for P cos 30 degrees minus 0.3 Na equals to 50 AX. 50 is the mass given here. But we have Na unknown. We have AX unknown. So we cannot solve this equation yet. Then we go to the y-axis, Fy. What is Fy equals to? Fy is referring to the free body diagram, the left-hand side of the equation. The right-hand side of the equation, if you look at the kinetic diagram, do you have anything in y-axis? Yes, you don't have anything in y-axis, so it will be equal to 0. Okay, so you will write Fy is equal to 0. Okay, Now you will take all the forces acting in y-axis. So you have normal force NA pointing up, positive. Then you have P component in y, which is P sine of 30 degrees pointing up also, which will be positive as well. And you have mg pointing ke bawah, pointing down. So mg will be negative. So you write down all this equal to 0. Alright. So then you will substitute all the values lah. You will bring mg and also p sine 30 to the right hand side to get the value of NA. Okay, from this calculation, from Fy, you get NA equals to 290.5 Newton. Okay. When we have NA equals to 290.5, we can then substitute in our first equation. Okay, we can substitute in here to get the value of AX. Okay, AX is equal to 5.185 meter per second square. Okay, this is the unit for acceleration. Okay, but that does not solve our problem yet, because you see here, we are asked to determine the velocity of the crate 3 seconds starting from rest. What we have here is the acceleration. Okay, this is where if you look at the analysis procedure, number 7, if velocity is to be determined, kinematics equation needs to be used. So we need to use kinematics equation here. Okay, we need to use kinematics equation. So how to use kinematics equation? We know that pulling force here is constant. Dia bagi tahu sini P is 400 Newton, doesn't change with time. So it will be constant 400 Newton pulling, 400 Newton throughout the motion. Therefore, when P is constant, AX ataupun the acceleration that we have calculated before, AX will also be constant. So when you have a constant acceleration, then you can go back to chapter 1 kinematics, where you have 3 equations for constant acceleration that you can use, and to determine the velocity we can use this equation. V is equal to V naught plus ACT. Okay, AC here is equal to AX lah. The constant acceleration in this case is equivalent to AX that we have calculated before. Okay, what is V naught here? V naught, the initial velocity. What is the initial velocity? 0, correct. Amar, thank you. Because it says starting from rest. Okay, starting from rest means that the initial velocity V naught is equal to 0. Okay, so now we have all the values, then we can substitute lah. V is equal to 0 plus AC is equal to AX, so 5.185. T is 3 seconds. As mentioned in the question, 3 seconds starting from rest. So then we have our velocity V is equal to 15.56 meter per second. Okay, so that solved the problem here. Do you have any question? Ada apa-apa soalan? Any question on the first example? Semua jelas?
Jelas, sir.
Okay, so if that is clear, let's look at our second example problem. Okay, now we have a motor at M here. This is a motor winding the cable. Motor ni pusing, so the cable will be pulled with a constant acceleration, such that the crate, the 20 kg box here, will move 6 meter in 3 seconds starting from rest. The question is, determine the tension developed in the cable and it says that the coefficient of kinetic friction is mu k 0.3. So we know that this surface is rough. There will be friction also. Okay, so what is the first step? What is the first step to solve the problem?
Coordinate system.
Coordinate system. So how are you going to define the coordinate system? Do you want to define it as a normal orientation, x positive to the right, y positive up? Or how do you think it is better to define the coordinate system in this case?
The first one, XY.
Sorry? The normal orientation.
The XY.
XY, betul. We are in the chapter subtopic rectangular coordinate, so we will use XY. But okay, let's look at the motion. The box here being pulled by the motor will move in this direction. Betul tak? Dia akan move in this direction. So, to make the calculation easier, we can define our coordinate system like this at similar inclination angle. So x will be positive in the same direction as the direction of travel of the box, and y we can define y as positive, pointing up lah, 90 degrees to x. So this will make the calculation easier when we define the coordinate system this way. Okay, second step is to draw free body diagram. So how do you draw the free body diagram? What are the forces acting on the box?
Wait.
There will be a weight, yes. So weight akan point ke mana? Point sengit. Macam ni.
To the ground. Ke bawah.
Ke bawah straight ke bawah sengit at an angle?
Bawah straight. Y-axis bukan Y-axis. Straight.
Straight, betul. Remember, the weight will never acting in at any angle. Walaupun kita define our y-axis like this, the weight will not being applied this way. The weight will always be straight down. Okay, mg will always be straight down. But the normal force will always follow the axis. So kalau y-axis tu macam ni, normal force will follow the surface ni lah. Will follow the surface because the normal force is the force acting as a result of a contact between the object and the surface. So remember, weight will always point down, normal force will follow the surface punya angle. Okay, then we have friction. Okay, friction. We know the box is moving up, so the friction must be pointing down. Okay, apa lagi yang kita ada? Force acting on the box. Ada lagi tak force lain?
Tension.
Tension, correct. This is what we want to find. Determine the tension developed in the cable. So the tension will be pointing towards the direction of motion lah. Tension ni akan act pointing up. The tension T. Okay, that completes the free body diagram. Now we go to the kinetic diagram. Okay, how many arrows do you have for kinetic diagram?
I think 1.
In y-axis or in x-axis?
X-axis.
Correct. In x-axis, 1 arrow, max, because the box is not moving up and down. Okay. Let's say kita define our coordinate system ni macam biasa, as a normal orientation of coordinate system. X positive to the right, y positive pointing up. In kinetic diagram, how many arrows will you have? Kalau coordinate system kita orientation macam biasa.
There will be 2.
Correct. There will be 2 because this is the direction of motion. Kalau axis kita X positif ke kanan, Y positif up. So you will have components in this direction, MAX, and you will have another component, MAY, in this direction. That is why I said when you define your coordinate system following the direction of motion of the particle of the object, then it will make the calculation easier. Okay, you will not have any component in y, so Fy will be equal to 0. Okay. So once we have the free body diagram and kinetic diagram, we will write down the equation of motion in x and y axis lah. Okay, so sum of force in x axis equal to max. In x axis you have tension positive, you have friction negative, and then you have component of weight. Mg ni you can pecahkan into x and y component. So you have T positive minus friction and also minus the component of weight minus mg sine 30 degrees equal to max. Okay, there are a lot of things that we don't know here. We don't know tension, we don't know the friction because we don't know what is NA, the normal force, and we don't know what is AX. So we cannot solve anything from the first equation. Now we go to the second equation, which is Fy equals to 0. Okay, from here you have normal force positive minus the component of weight mg cos 30 degrees. So you can rearrange, becomes Na equals to mg cos 30 degrees equal to 169.9 Newton. Okay, this will be the value of Na. Okay, and it says in the question, the motor winds the cable with a constant acceleration. Okay, with a constant acceleration. So then we can use the kinematics chapter 1 punya equation for constant acceleration to find what is AX here. What is AX? Kita dah tahu NA, so we can find our friction force because we have the mu here. But we want to find the tension, we need to know what is the acceleration. AX ini kita tak tahu lagi. So we can use the constant acceleration punya equation to find what is the value of AX. And it says here, the crate move 6 meter in 3 seconds. So we can use this equation, S is equal to S naught plus V naught T plus half ACT square to find what is AX. AC in this case is equal to AX lah. Okay. What is S naught and V naught? S naught and V naught. What is the value of these two?
0.
0, because it says here starting from rest. Okay, starting from rest meaning that there is no initial position, there is no initial velocity. Okay, the displacement is given 6 meters, so 6 is equal to 0 plus 0 plus 1 over 2 AX. Time is also given 3 seconds, so 3 square. So from here we can get AX is 1.333 meter per second square. This is our acceleration in X axis. Okay, so we can then substitute all the values in the first equation di atas ni to get what is the value of T. Okay, so T is equal to M times AX, which is 20 times 1.333. We can bring friction to the right, becomes plus friction is mu K 0.3 multiply with NA 169.9 this one, we can bring mg sine 30 to the right becomes plus 20 times g sine 30. Okay, so in the end, we will get the tension is 175.7 Newton. Okay, any question? Is this clear?
Clear, sir.
Okay, so in the first example, I have shown how to solve the problems when using normal orientation of the coordinate system. Okay, normal orientation of the coordinate system, and the question asks us to determine the velocity. So you need to apply the kinematics equation to get the velocity. And in the second example, I have shown that you can also define the coordinate system in different orientation depending on the situation. In this case, the box is moving at an inclined angle of 30 degrees. So to make the calculation easier, we can also define the coordinate system to follow the motion of the object. And then this is also a problem where you have to use some equations from chapter 1 from kinematics to get the value of acceleration in this case. And finally, we determine the value of the tension in the cable. Okay, let's look at one last problem before we proceed with the quiz. Okay, example number 3. If motor M exerts a force of F equals to 10 t square plus 100, what is the difference between this problem and the previous problem? Apa perbezaan dia?
Orientation.
Okay, orientation betul, satu. Yang kedua is the previous problem, the previous two problems, the force is constant. Macam yang pertama tadi, 400 Newton constant. Throughout the motion, tak kira masa 4 seconds, 2 seconds, 3 seconds, the force applied is constant. But in this case, the force is changing over time. You see, the force is given as a function of time. Force is equal to 10 t square plus 100, meaning that the force berubah mengikut masa. Okay, so that is the difference lah between the previous problem with this one. And again, we need to determine the velocity of the 25 kg crate when t equals to 4 seconds. The coefficient of static and kinetic friction is mu s 0.3, mu k 0.25. Okay, now this is another difference from previous problem. Previously, you only get one friction coefficient. Now there are two friction coefficient given. One is coefficient of static friction, the other one is coefficient of kinetic friction. Which one should you use? And what is the difference between these two? Apa beza dia? Siapa tahu? Siapa tahu?
Static masa track tu tak bergerak.
Correct.
Kinetic waktu bergerak.
Yes. If the box stays, for example, at an inclined angle, tapi dia tidak bergerak, meaning that the coefficient of static friction is applied lah, is used in that case. Tapi apabila dia bergerak, if we go back to our previous problem, all of the problem you see the problem gives the coefficient of kinetic friction because the box is moving. So in this case, we need to determine whether the box ni pada awalnya dia static dulu ke ataupun dia terus bergerak. Kalau pada awalnya static dulu, then we need to use mu s in the beginning. Then bila box to start to move, we then use mu k. But we need to determine whether the box tu, after the motor is turned on, the box will immediately move ataupun the box tu static dulu. So meaning that if the box is static first, the force exerted by the motor ni, the force applied by the motor belum cukup kuat untuk tarik dia. So walaupun the motor has already turned on, the box may not move yet. Because of the friction. Ataupun because of the mass tadi, the inertia yang resist the motion. So that we need to determine first. Okay, again, the first step is to define the coordinate system. So in this case, we know the box is moving to the right. So there is no need to define the coordinate system at an angle. So we just use the normal orientation lah. X positif ke kanan, Y positif ke atas. Okay, then we draw the free body diagram. Free body diagram ada 4 force macam biasa. Weight is pointing down, normal is pointing up, there is friction to the left, and there is force by the motor pointing to the right. Okay, kinetic diagram ada satu sahaja force, ada satu sahaja arrow, MAX, because we know the box is not moving in y-axis. There is only motion in x-axis. Okay. Now, before we go to equation of motion in x-axis, we write down the equation of motion in y-axis first because we need to know what is NA. Okay, from our free body diagram, we know that NA positive minus mg is equal to 0. So NA is equal to mg is equal to 245.3 Newton. Now, we need to know initially when t equals to 0, berapa force dia. So, we key in the value of time equals to 0 in this function, in the force function. So, we get when t equals to 0, force is 100 Newton. So, force given by the motor pulling the box, the crate, is 100 Newton. So we need to know whether 100 Newton is bigger than friction force or lower than friction force. If it is larger than the friction force using static coefficient, then the box will move immediately. So maximum static friction is mu s times NA, which is 73.58. 73.58 Newton is smaller than the force given by the motor. So since the force by the motor is larger than the maximum static friction, the crate move immediately when the force by the motor is applied. Okay, when the force by the motor is applied. So we cannot use the mu s lah in this case because we know immediately the box will move. So we then use mu k. This is just a trick lah, a trick question lah, to test whether you know how to differentiate between static and kinetic friction, which one to use. So you cannot simply use any of the coefficient ni. You have to justify lah how to why you use mu k or why you use mu n. So this is how you justify. You calculate the maximum static friction, you calculate the force, and you see that the force is larger than the maximum static friction, then you know that the crates move immediately when the force F is applied. So we need to use mu k. Therefore, the friction is not mu s times NA, but it is mu k times NA, which is 61.33 Newton. Okay, then we go to the equation of motion in x-axis. Tadi kita dah calculate equation of motion in y-axis to get the value of NA. Now we go to the equation of motion in x-axis. In x-axis, we see positive F force minus the friction equals to MAX. What we want to know is the velocity, but we solve this first. So, the force here is given by this function, 10t square plus 100. This is the force, depending on time. Friction force, kita dah calculate in the previous slide, 61.33 using mu k. We have justified why we use mu k. Mass is 25, AX 25 AX. Okay. So how do we get V, the velocity, from A here? Can we use the constant acceleration punya equation tak? Can we use the equation for constant acceleration like what we did with the previous example? Boleh ke tak boleh? Use the equation for constant acceleration. Boleh tak? Tak tahu. Cannot. Tan kata cannot. Why cannot? Why cannot? Because the force applied is changing with time. It's not constant. When the force applied is not constant, you know force equals to MA, meaning that A is also not constant. When A is not constant, we cannot use the constant acceleration punya equation lah. So, from this equation, then we can get AX is equal to 0.4 t square. Ini selepas you minus 100 minus 61.33, and all of this you divide by 25. So you get 0.4 t square plus 1.547. So how do you get V from this? Is by using the basic kinematic equation, which is A is equal to dV over dt. So you have to use a little bit of integration in this case. You can bring dt to the A here, and then we integrate dv to get V. Integrate dv from 0 to V because it starts from rest, so 0 to the current velocity that we want. And integrate the acceleration from 0 to 4. Why 4? Because it says here when t equals to 4 seconds. This is when we want to know what is the velocity. So that's why we integrate from 0, initial time 0, to the t equals to 4. So on the left hand side, you get V. Integrate nothing dv, you get V lah. Integrate A here, you will get 0.4 over 3 t to the power of 3 plus 1.547 times t. Okay, this is what you have after you integrate AX lah, after you integrate AX. Then you will calculate for 4 and 0. This is the range. So in the end, you will get, when you key in 4 in the equation here, 0, when you key in 0, you will get 0 lah. You key in 4, you will get V is equal to 14.72 meter per second. So this is the velocity, and this example is showing a non-constant force, which is the acceleration will also not constant. So you have to use the basic kinematic equation to solve the problem, and you will get the value of velocity V is equal to 14.72 meter per second. Okay, any question? Do you have any question? Clear?
Clear, sir.
Okay, what about the rest? Yang lain pun clear? Okay, so kalau semua clear, that is all that I want to share with you today. So the summary for today's lesson, we have learned about 3 Newton's law of motion. We have learned about the equation of motion, F equals to ma, and we have learned how to apply the equation of motion in respective axis, Fx equals to max, Fy equals to may, to solve related problems. So this is what we have done today. So if you don't have any question, we can go straight to the quiz lah. So please get ready with a piece of paper. Are you ready now?
Why that, sir?
Release date for midterm. What do you mean release date for midterm? Maksud you bila midterm exam? I have shown in the first class kan, kita punya planning. Sekejap Wait, let me see. Okay, in the first class, I have shown this planning for the whole semester, and currently we are in rectangular coordinates. Kita kat sini, 7 April, rectangular coordinates. Okay, do you see this? Boleh nampak kan apa yang saya tengah tunjuk ni? Boleh nampak ke?
Boleh, sir.
Okay. Okay, so kita sekarang pada 7 April, equation of motion rectangular, and this is week number 6, minggu ke-6. So next week, week 7, we will cover 2 more chapters, and we will have a quiz also next week, ataupun maybe we can do the quiz during mid-sem break. Quiz ni doesn't matter, whenever you want lah, whenever you are ready. Tapi after the mid-sem break, 26 April, we're gonna have test 1 during the class. Test 1 ni hari Isnin, 26 April is Monday. Test 1 will be during class 2 to 4. Saya tak buat macam kelas-kelas lain, probably you have the test malam dan sebagainya. So our test will be during class time, 2 to 4. So we will finish with chapter 2 before the mid-sem break. I will try to finish during before mid-sem break, and during mid-sem break you can study chapter 1 and chapter 2, and test 1 will cover both chapter lah, chapter 1 dan chapter 2, which will be on the 26th of April. So after test 1 we have finished with 2 chapters, then we will continue with 2 more chapters, and then there will be test 2 at the end of the semester, week 14. Lepas tu akan ada final exam lah. Okay? Jelas?
Okay, sir.
Okay. Okay. So I hope now you are ready for quiz 2. So like before, quiz 2 will be in Google form. So what I want you to do is you will have to prepare a piece of paper, okay? And don't forget to write your name, your ID number on that paper, and I will share the link to this Google form after this, and you will key in your email address and choose your name, press next, and you will be displayed with the question. So you will answer the question on the paper, and then you will scan your answer using any application that you have lah, cam scanner ke, office lens ke, adobe scan ke, whatever, and then you upload in the Google form and submit. Okay, you have 20 minutes to answer. Whenever you are ready, you tell me, I will share the link. Okay, are you ready now?
Yes, sir.
Okay, semua dah ready? I will share the link in the Google Meet and also in the WhatsApp group. And before that, can you please turn on your camera? Okay, this will be just a short quiz. 20 minutes is the time that you have to answer. So now is 3:15. So your submission will be 3:35. 3:35. You have 5 minutes for submission. Okay, so if you are ready, I will share the link now. Okay, in the Google Meet I have shared. I will also share in the WhatsApp group. Okay, you can start now. Good luck. And I will tell you once the time is done. Okay.